Hello everyone, welcome to my class. In the previous class, we have learned about the definition of data structure, the classification of data structure, under which we have learned primitive, non-primitive data structure, linear, non-linear data structure, the operation of data structure, algorithm, and what is abstract data type, all these things. Today our discussion topic will be the linear and non-linear data structure in brief. So, as we know, as we have studied in the previous lecture, that under non-primitive data structure, we have linear data structure and non-linear data structure. And under this linear data structure, we have to study array, linked list, stack, queue, and non-linear data structure, tree and graph we have to study. So first, we will talk about this array. So what is an array? An array is a collection of homogeneous data, or you may say it's similar data types elements can be stored in an array, and they must be stored in contiguous memory location, means one after another. What the picture says that is a slice of chocolate. That is like a matrix. This is 1 2 3 4 5 5 cross 2 matrix is there, and they are one after another, they're attached with each other. And for array, if we know the address of the first element, then we can easily find out the address of other element present on that array. Now this, for array, we have to declare the size of it in the program at the very beginning, and the memory required for this number of element will be stored, will be occupied at the compile time. And that is the big disadvantage of array. Suppose we have declared an array of size 100 and we have stored only 40 elements there. Then what will happen? Remaining 60 elements memory will be occupied at the compilation time, because we need to store the data in contiguous memory location, but we are not using that 60 memory blocks to store the element. So there will be wastage of memory in case of array. So this is all about array. Then we will learn how to store the data, what will be the location in later on. Then we will go for the linked list. As the picture denote that those are the coaches. Those are the coaches where all these three coaches are like a chain, means one can move from here to here to here to here like this. They all are joined together. Okay. Now we can reach to this via traverse this node also. So there is a linked approach. For a linked list, there are two fields. One is the information. Information means what element we are storing. We can store one integer value, we can store a character value, we can store a float value over there. The information part should be there, and the second part will contain the address of its next node. For this is holding the address of this, like this way. Means for linked list, it is also a linear data structure, and it have two parts. First one is the information, and second one is the address of its next node. Second one is the address of its next node. So this is the linked list. Here, for occupying the memory, we will do the same by using dynamic memory allocation. So what will happen? We need not to occupy the memory. We need not to specify the number of element which we want to store at the very beginning. And the memory occupied for that will be exactly same the number of element we are storing. So the advantage of linked list is there is no wastage of memory. If we don't require any element, we can free the position also. So this is the very big advantage of linked list over array. Means, and there is no concept of contiguous memory location, but one should hold the address of the next node. It may be in different position, but it should hold the address of its next node as the second part denote. So this is the linked list. Next we'll go for stack. Stack is also a linear data structure, and you can see the picture. This is the stack. Suppose we want this red book. So what we have to do? We have to remove all the books from the above. Then we can get this book. Okay. And for stack, this insertion operation is known as push operation. And the deletion is known as pop operation. Means whenever we will talk about stack, we have to talk, if we are inserting any value, we have to tell that we are pushing the value. Whenever we are deleting the value, we have to say that we are popping the value. Okay. So so here, as I have said, that to get this red book, we have to remove all the books. So in which manner we have kept the books? First we have kept this book, the last one, and last we have kept this book. So to get this book, we will not remove this from here. First we have to remove all the books above it. So last we have kept this book, last in value will be deleted first or popped out first. So this is last in, first out. Last in, first out. So whenever we are storing the data in the top of the list, then it will be like stack. Then what is queue? All of you have visited a shopping mall or a railway ticket counter. So where we can see a queue, a line. Means suppose we have to buy a ticket, then we have to maintain the queue. The person who is in front of me, he will get his or her turn first to get the ticket. Like train ticket reservation. All of we have seen that there is a waiting list concept. So whenever the queue will be full, all seat will be occupied, then all will be kept in the waiting list queue. And whenever someone will cancel the ticket, the first person will get his or her chance first. So this is a queue, and the insertion of this in this queue will be always from the rear end. It will be always from the rear end. Means for a ticket counter, it will be at the last. And the deletion, it will be always from the front end. Means who will be in the front of the queue. So it is first in, first out. Who will be in the first in the queue, he or she will get his turn first. So it is first in, first out. This is the linear data structure. Next, we will learn about the non-linear data structure. The non-linear data structure, as we know, it may have more than two neighbors. Means if we are following what example I have given to you, that if under JIS group, suppose there are 5 colleges under which GNIT is one of them, and for GNIT there have suppose 7 department. So there is a hierarchy, or you can talk about a student is under some mentor. Suppose student is facing some problem, so what he or she will do, he will approach to his or her mentor. Then the mentor will convey the information to head of the department. Then head of the department can convey the same to principal sir. So what we are following? We are following a hierarchy. So nonlinear data structure, the tree follows a hierarchy. Okay, so this is the root node. This is the root node, and this root node have 3 children. This root node have 3 children. The leftmost node have 2 children, means these 2 are the children of this, and this red one is the ancestor of all these nodes. And these 3 are siblings. These yellow and red, those are the siblings. Those are the siblings. Okay. So, and one most important thing what we should remember, that for tree there is no cycle. There is no closed loop. Okay. This is the most important thing for tree. Next, we'll go for the graph. Graph is also a nonlinear data structure. It consists of set of vertex and edges. Like it was all about edges and nodes, for this graph we will talk about the vertex and the edges. Now, what the picture says, that those are the points. Those are the, suppose those are the countries. Okay, so someone is moving from one country to another. There are several ways to reach them. So what we are doing, those are the vertex A, B, C, D. Those are the vertex. Okay, and we have to reach. We can reach to each and every one from any point. And so those aeroplane are connecting this point. So these will be the edges. And there are 1, 2, 3, 4, 5, 6, like suppose 7 edges are there or 6 edges are there. So this graph is consist of the set of edges and vertices. But for a graph, there may have the closed loop. And that is the main difference between a stack and a tree. Sorry, tree and a graph. So this graph, the good example can be the map. Means from any point we can reach to any other point. They may have different, what I can say, different paths to reach them. Okay, and there we have to study what are the minimum cost to reach from one point to another. So this is all about the brief of nonlinear data structure. The next class we will learn about the linear data structure in details. The topic will be array. So thank you. If you have any question, you can write me at trishita.ghosh@gnit.ac.in. So thank you all. Thank you for giving your valuable time. Thank you once again.